And hello! Did you like our new intro countdown thing? Um,
Ooh,
it did go for a bit too long, to be honest.
yeah.
And I think the song is repeating twice, 3 times. So I put a note that we need to fix that. Um, with that being said, hello everybody, and welcome to another edition of DevBeardOps. We haven't been on for 2 weeks, I believe. We skipped three
Three.
week three.
3 weeks.
It
Yes,
seems like
it's been
forever.
almost a month.
It's been almost a month since been away. A lot of stuff has happened between then and now, so we are finally back and gonna keep on kicking as we go along. So thank you very much for joining us. Um, Today's show. First of all, we've been messing around with audio. Let us know if Kobus's audio. Kobus, say something.
Hello.
Hello. Is our audio okay? Is it in line? Is somebody too loud or too soft? We try to fix this, but we uh, struggling. So, and welcome back to all the people who have been joining us before, and all the new folks as well. So today, what is it about today? Today we're going to be talking about all 18 uh, options. We're really not going to be talking about all 18, but we're going to be talking about container options on AWS.
Yes.
Which one is right for you? What are their drawbacks? What are their positives? And how to pick the best one for you. But before we get into that, we have a fancy intro. Thanks to our
Ooh.
colleague. Thanks to our colleague Toby. So check it out. This now looks like a professionally produced show, isn't it? Right?
Finally.
Finally, we have something we didn't have to scrape from the bottom of the internet barrel. So, welcome, Asantos. Welcome back. We have TypeScript tea time again. Welcome all back, and it's really, really nice to have you here. And welcome to all the new folks. Surly Dev, welcome back. This is not an Amiga 1200; it's an Amiga 600. So
if
it's
you get two of those, it's the 1200, right?
exactly. So you have to stack two of those on top to get a 1200. So, okay, Kobus,
Yes.
let's kick it off. Tell us what the problem is.
So, one of the reasons we've been very quiet the last while is that, as you know, there's the thing called reInvent coming up at the end of the year. And unlike where it starts at the end of November for everyone who's attending, either virtually or in person, it starts for us pretty much in May already. I think we had the first kickoff calls and things.
Yes.
There is a lot of planning that goes into there. And I don't think we're allowed to share our session yet, Darko, in terms of what we'll be doing. But we can just say that, it involves containers and automation and some fun things. So as part of that, we've been spending quite a lot of time looking at containers and things.
I think we can say it. I think our session is already being shared online. So
I
think you can see the agenda for reInvent. So if you registered, you can see the agenda. Basically, Kobus and I are working on something to do with ECS and anywhere. You combine the two and you get containers anywhere. So yeah, it's containers.
There might be some Raspberry Pis thrown in the middle.
Some Raspberry Pi, yes. So if you're looking to listen about us talking about containers everywhere, all over the world, running on different places, so make sure to register for reInvent and check those things out as well. Okay.
And then on top of that, there's also a bunch of content that we're busy working on in the bigger AWS sense of things, like that we'll be publishing soon-ish. Once again, wait, we can't say yet when it comes out. But it does involve a whole lot of containers and things around that. So I have been neck deep in all the different ways to run containers and trying to make choices around that, which has been proving interesting, because Doc was actually not joking when he said there are 17 ways to run containers.
18.
I know.
I think it's 18. I think it's 18 now.
No, it's actually 34. Because Corey Quinn, in his awesome snarky way, he first published the thing called 17 Ways to Run Containers on AWS.
Okay.
And then he realized that there are some other ways you can also do it, like some weird ways, like if you use something like AWS Batch. And technically, you can run containers under the hood for things like Nimble Game Studio or Nimble Studios and a whole bunch of those other ones. So effectively, you went through all of them, and then,
I mean, code builders containers technically. So
no, code builds containers. You can even have your own container in there. Yeah. Yeah.
Okay.
And yes, Ricardo, not 42, please. No.
Yeah. But I mean, of course, we're not going to be talking about all the 34 ways to run
No.
containers. We're going to be
No,
talking
no.
about the meaningful ones to run containers and what they mean for
Yeah.
you. And because that's a common question. A common question is
Yeah.
like, Darko, should I use EKS, ECS, Elastic Beanstalk? Should I just run my containers on EC2 instances? Should I do Copilot, App Runner? I don't even know. Like, so this is where we get to kind of go into that discussion.
Yes. Yeah. So I think before we dig into that, it's just important to understand all the different components into going from here's a site running with containers or an app running with containers, and how did we get there? Because that is already where the classic "it depends" question comes in. And I think I'm actually just going to put a disclaimer down here at the bottom to keep us out of trouble, because this will be one of those things where it's opinionated. So let me just do that.
While Cobus does that, I'm going to say hello to all the folks. Ricardo, welcome to the stream. We like to have you here. Lord ZMD, the Beard Brothers teams. We're not brothers, but almost. If you only count the beard, and ZB_C, hey, welcome back. We are good. We've been away for 3 weeks, and we're super happy to be back and doing a bit of live streams on this case. Okay, yeah. Personal opinion.
There we go. See, now we're safe. I know Ricardo is watching us, so hopefully we don't get into all troubles. It's just one of those funny things. Like, we're allowed to have opinions, but we have to be very clear when it's our opinion and not, our employer's opinion. Yes, and I just broke Darko again, and I didn't even tell a joke.
There you go. Yeah, I missed the dad jokes. Okay.
Yeah. So starting off, you want to run a container. So the first question is, where does that container come from? Is it something that's being hosted on a public repository somewhere that you can just pull and run? Maybe pass it some config values and you're happy to go. Or is it something where you have the image in a private repo or someone else's private repo? And also then the question before that becomes, how did it get there? As in, did you do a local build and push it? Did you have a CI/CD pipeline to push it? Do you need all of that? Because at the end of the day, with containers, it's kind of like difficult to say, well, here's the one true way to run them. For that, it's because all of those things will play into that. And I mean, based on those different scenarios, the ones that I thought we should look at today would be Lightsail, App Runner, Elastic Beanstalk, ECS with 2 flavors, and then also EKS. Because those are the main 2 ones. I'm not going to cover, for example, just using an EC2 instance and getting your container running on it yourself. I mean, you're welcome to do that. I used to do that even with customers when I was doing consulting, to get them on, get it going, because I at one point didn't like ECS until I really understood it, and then I just ran everything on that. But yeah. Good question here from Shendril, which is Proton. Proton is slightly more complex in the sense that it means you create templates for running your containers. So it's slightly more, we know how to run them. Now let's templatize that and actually expose that to our internal, dev teams to actually be able to run it. It's more like if you've got a dedicated platform, or what people often call the DevOps team.
It's not an orchestration. It's not an orchestration platform per se, right? It's not like for orchestrating containers, services, and all those things. It's more of a way to kind of standardize a bunch of things and have different teams deploy the same thing. So
so that's kind of it. So let us quickly run through, and I've got some sample code over here. We'll see. I just ran because I'm used to running on my MacBook for work and running things. I decided, well, I'm going to do a screen share, and I'm going to do it with Windows Subsystem for Linux 2 on my Windows desktop, which I'm streaming from at the moment. And that also already was like a couple of hoops to, just get it working. And I'm expecting there are going to be a hiccup or 2 here with some of the demos and things.
Right.
Yeah.
Okay.
So first off, let us quickly, let me just see if come on. I need to get the Windows. We can get the sharing going. That can go over there.
So while Cobus is doing that, just gonna address a couple of basic questions here. Why containers? Like, first of all, why would you run an application on container? And I had these discussions with people. Like, is a container just a virtualization inside of a virtualization? Not exactly. Basically, a containerized application is just sticking all of your application dependencies, all of the things that you need to run an application in something, a container, called a container, right? So think of it as a almost self-sufficient piece of application that can just run quote unquote anywhere. And the beauty of containers is it's basically an ability to run containers. You can say it works on my laptop, and it almost always should work in production because you are using, in essence, the same type of environment where your application code runs. So you're not virtualizing a virtual machine. You're not doing the entire full stack, just all the dependencies required for the application. And I believe it's wonderful, right? I've used containers initially, like for things. A long time ago, I used to have like a build environment, not a build environment, a development environment with my tools in a container. So I would create a container image and I would move it with me. So on any laptop I go in, I can just I can shell into my container and do stuff from within my container with all my tools and stuff. So wonderful. So Cobus, did you not give the sacrifices to the demo
I
god?
did. I just need to click the buttons. Share the screen.
Dan MBA, I think he asked like, what's the deal with virtual reInvent this year? So I don't still have 100% information, but it's going to be in person, right? That's the current state of things. It's happening in person in Las Vegas, but there's going to be some virtual stuff. There's going to be some sessions that are going to be available on demand for you to watch. So please stay tuned with that.
Cool. Let me just.
Lord ZMD, I'm going to attempt to go there in person. I believe Cobus will not be able to make it, but I will do my best to go, and I cannot guarantee that I will be there. So.
Yeah, I mean, to put that in perspective, the reason for me is like I've got two very young kids at the moment, and also the travel restrictions are so uncertain. So if I, for whatever reason, get caught on the way back or on the way there having to quarantine, firstly on the way there I miss reInvent. On the way back, it means I'm effectively 3 weeks away from home and from my kids. So yeah.
So exactly. So if I'm there, Lord ZMD, let's have a beer. Please do let me know. I'll let you know also if I'm there. We're gonna see me there. So, but yeah, Cobus, can we bring in the screen share? Is it ready?
We can bring in this. Hopefully, we'll see. It's as you can see, very still getting started. Like I said, I normally play with my Windows desktop and develop, but I'm not testing it out. One thing here that I must say, which was really nice now, is I just did the following, which is in here. As you can see on that little line over there, I just went code dot. And the integration with Visual Studio Code is nice. It just literally popped up or installed whatever it needed. I don't know. And boom, here we go. I can actually access the files inside my VM. So first up, what we want to look at is that, like I said, depending on what you want to try and do. So let's start off with probably the easiest way just to get a container up and running, which is going to be with either AppRunner or with Lightsail, depending on what you want to try and do and how you want to try and do it. So with AppRunner, how it works is that if I open up here, I think we covered this in a previous one. Basically, you say create service. You can click on these, and you can see over here, it's fairly easy. You just click through and actually get it up and running. And what this does is it just runs the single container for you. And under the hood, it uses Fargate. So this is a simple way to do it. The benefit here is that you can integrate with a couple of different AWS services because you can assign some permissions to this, host underneath the hoods, or underneath the hood that you are dealing with.
Right.
Whereas, let's say if we go to the Lightsail, fire this up quickly, and this console does look completely different. Let's just hide that. Yes, I'll create something later. You can see over here, there's a containers option over here. So let's quickly just dive into what the basic differences are here. The first one is that between AppRunner, which is one of the more, I'd say, traditional ways that AWS services work, which is per usage billing, a Lightsail's got a fixed cost per month. Instead of saying, like, depending on exactly how many seconds the instance was up, type of thing, you can see over here, you can see the different pricing models available. And let's just get that out of the way. And also you can see there is a nice free tier here with you to play with. Unfortunately, AppRunner doesn't have a free tier for us to play with. Where'd my docs not? There we go. Cool, there's my notes. So you can see how it works over here. It's very simple. It's not meant to, out of the box in Lightsail, be for microservices. You can obviously, as with any kind of technology, you can build microservices by spinning up individual nodes and then doing all the hard wiring between them. That's not the point of Lightsail. Remember, Lightsail is focused on being the simplest way to get up one specific app, or let's say a couple of containers together and run them as a single unit and then deploy that. So the nice part here is that it's simple, fixed cost per month. You see you've got a couple of scaling options. When you look at the actual Lightsail options over here, you can add a RDS database,
Okay.
some storage, networking, like for example, your load balance, all of that. Now, where the difference between the two come in is Lightsail does not currently support IAM roles at the moment, and also because of that, the knock-on effect is that it doesn't support easy integration, for example, with ECR, where you can just say pull my container from ECR and do it. So the workflow between the two is different. So with Lightsail, you typically go and say, you create your Lightsail container instance, then using the CLI, you'd say, okay, cool, go push a Docker image that you built and push it to your Lightsail service as a deployment. And then you say, okay, Lightsail, and I'll use that deployment in the container service. Big difference. So once again, first question here is like, why would people want to do this? Well, the simple answer is that not everybody needs a fully automated CI/CD pipeline.
Exactly. Yeah. Sometimes you just want a simple application running within a container. Here's an example. Does anybody here run like what is it called, the Pi-hole, right? Like the little home DNS blocking tool. It runs on a Raspberry Pi. It's wonderful. For a thing like that, you don't really need a proper CI/CD pipeline to deploy applications as that or services such as that. So for like an appliance, it's wonderful just to deploy a container somewhere and it runs. So I think this is just a very valid use case for this. And it's simple, super efficient. And I think the beauty of this is it's very much, it's predictable because you know exactly how much does it cost per month. So wonderful.
Yeah. I actually want to show you quickly. I just want to grab I've got the code here somewhere. I've got too many container options here. There we go. So, sorry, blom, blom, blom. We've got the container. Can I get this code onto you is the question. I'm sorry, I'm just jumping between the two machines. I realized that I didn't copy it across. I will not, but I can show you some of the commands. Let me do that. Okay. Basically, let's assume...
Yeah. Ricardo asks, is this still the case if you host your containers via ECR public? You can use ECR public containers for this case?
Then you can pull, because just remember, you don't have any embedded credentials like an IAM role that allows you to access other AWS services at this point. So that's, once again, as with anything, there are workarounds. There are ways where you can actually configure the credentials, passing them in as environment variables into the container, etc. There are many ways you can actually get around that, but by default, there's no use this IAM role. Don't let me worry about rotating the credential keys and things at the moment in Lightsail. Yeah. So basically what you do, let me grab the commands, is that, there we go.
Okay. While Kobus is grabbing commands, just to answer ZB_C, and I like this comment. Lightsail is a great VPS with AWS reliability. Again, it's all built on AWS and it's super simple for you to get into. If I have friends who build stuff with a very simple interface on AWS, Lightsail is just chef's kiss for that. Okay.
Oh, let's see if it actually has got this. No, bash, maybe. It doesn't have bash in here. I'm very...
Shell script.
Yeah, okay, we're not going to get colors today. Sorry. Cool. Boo. So basically what you can see here is now to get it up and running on Lightsail is you can either click in the console. I'm like in two minds about this with Lightsail, to be honest, because on the one hand, it's so simple, it's so easy to click. It's almost as fast doing it in the console as it is doing with the CLI. The difference for me, though, is that it's easier to put the CLI stuff in a document for someone else to follow than to say, go click here, screenshot, go click there, screenshot, or animated, shall I cause an issue? Animated GIF, I mean joke, GIF. It's a GIF. It's not a GIF. Yes. So, yes.
No. It's a GIF. It's a GIF. I fully agree. It's a GIF. It's not. I'm not gonna blaspheme here. So no. Absolutely. Okay. Cool. So in this case, it's basically just creating a little. This is using the AWS CLI, right?
Yeah.
Okay.
Correct. Yeah. And then what you need to do is when you get to this literally it's up and running, but it doesn't have a container because guess what? You didn't specify a container. You can see over there. I did not say what the container name needs to be. And how that part works is you first need to push the container. So let's say you want to get the push the container, you do something like this, which is, you can see, push the container image. Now, this immediately assumes that you've got the image locally. So to answer Ricardo's question earlier, what you can do is you can pull a public or a private image locally and then do the push yourself.
Okay.
Or if you're, let's say, running inside a code build job, this is the other way I've actually seen people do this, which is it's a little bit a weird combination of things, because if you're at a point where you're already happy with code build and, let's say, code pipeline and scripting things up, kind of feels like you might be ready to actually just work with what do you call it directly, with some of the other container services directly. But once again, different people have different needs. So you could have a code build container that just runs these commands for you once it's built the container, or pull it somewhere, push it to ECR, lots of options. So what you can see over here is that you can see this is the push container image. That's exactly what it does and only what it does. This does not yet put it on your Lightsail instance that you actually selected. To do that, what you actually have to do is, let me quickly grab it.
So the first command creates a service. The second command pushes a container image onto Lightsail.
Yes.
And is now available to use on a Lightsail service, right? Okay.
Yes. Now, this is where the fun part comes in, which is, and this is a little bit like, I'll show you how Elastic Beanstalk does as well. There's a little bit of similarity in the process there, given that it uses a JSON file to do it, which is you need to create a JSON file that actually looks a little bit like, let me actually just copy the whole command so you can see if you're running this in a console. Let's pop that here on a new one. So you can see over here what happens is that you're creating a file called lc.json, and in here what you see is you give it a service name of some kind, you tell it what containers to run in. Now, clarification here, a lot of the services on AWS that allow you to launch a container allows you to use a set of up to 10 containers in a single deployment. And the reason for that is, let's say you've got some extra containers, like you want to put a Nginx reverse proxy with, let's say, a container running Let's Encrypt to do your SSL certificates, and then your actual application container, or maybe add on a Redis container to, for caching, whatever it is. You can do all of these multiple containers in the definition, and then launch them as a single unit to run. So what you can see over here is, here we say, okay, cool, it's running signup_applications.latest. And the way we got that, let me just quickly scroll up here to my special notes, is from that actual deployment we pushed. So what that does is, if you run the command, let's go back to our command tab over here, put that over here, get container images, and you run this, what it'll do is it'll return a, sorry, Synergy is acting up since I switched screens. It will return a value that looks a little like this. And what you can see in there, the important part is the actual image name. So you can also see it feels like Docker in the sense that you know what the image name is. The difference here is now you've pushed it into Lightsail, and Lightsail can now reference that image internally based on do it. And then once you have all of that, you create that file, this where's my mouse? Sorry.
LCJSON.
Yeah, this one with all the details of it. And now you can finally go ahead. Come on. Sorry, my mouse is really giving me issues. And actually deploy it. And the way you deploy that ultimately is by running the Lightsail command. Oh, copy and paste. Copy. Let's try this again slowly. There we go. You tell Lightsail go create a container service deployment, and you give it the file. Now, inside the file, important here is you can see that we specified the service name, the container details, and also the public endpoint. So this is ultimately how you get it out there. So yeah, so for those that do want to do this, you can. Like I said, it's not that hard to get up and running, and this is a rinse and repeat process. So it's very easy to script this and get it up and running. But like I said, caveats around not having an IAM role and doing things. But it's simple, fixed cost per month. You don't have to worry about VPC, IAM roles, IAM credentials, depending, once again, what it is that you want to do.
Got it. Awesome. No, I think this is great. And I mean, you can do this to the command line, but you can also do this all through the web interface, right?
Oh, yeah. No. I mean, it's literally, if we, where'd that window go? Here, this one.
Yeah.
Great instance.
No, this is instance.
This is instance. No. Sorry. Containers. I was about to say, why is it giving me options? Cool, create one.
Okay.
Let's stick mini. Boom, boom, boom. Set deployment over here. You can say there are specific predefined ones, or you can say specific custom one. Yeah, you can see it can actually do it directly from a public repo now, which is awesome. Yeah, and then you can give it a custom launch command and boof, you're off through the races.
Yeah.
But like I said, here you can see there's no easy way for you to say get it from a private repo, because That's
can't, yeah.
just not built in terms of things.
Exactly.
Yeah.
I mean, so Mohammed here makes a great comment here. Run Dockerfile locally, push the image from your laptop to ECR. It has to be public though, right? There's no way
Yeah.
for you to actually push it to a private repository in this case.
Yeah.
So that's the way you can do it. But there's no way for you to kind of push this thing, at least from here, from a private, get the image from a private repo. So
Yeah.
Adrian asks, does Lightsail support running multi-containers or an equivalent of pods for ECS tasks?
It's not quite one-to-one mapping there, because remember, let's say on Kubernetes, when you're talking about pods, you can say, well, run multiple pods and manage them independently, or you can go daemon sets or sidecalls, and the different ways to do that. Lightsail is much simpler in the sense that you can give it a list of up to 10 containers and say, run these as a single unit. So then when you say scale out to 5 copies of this Lightsail instance size, it creates 5 identical ones of those with the exact same manifest file to actually deploy those. So you can then, in theory, like have replica sets of your pods in Kubernetes speak, or deployments, depending on which way you're going with it. So that's why it's close-ish, but it's not. It doesn't map one-to-one, unfortunately.
Yeah. Okay. Good. All right. So that is
Lightsail. One more question. AWS Lightsail CLI. I need to double check that. It's hilarious because I'm literally looking at that piece of the guide I'm working on later today just to confirm whether or not that's needed, because we did have it as a prerequisite step, and we're looking at if we need to remove it or not. So I'm busy cleaning up a guide that's coming out on this.
I mean, Lightsail is part of just like the AWS CLI. I mean, I'm not really sure that there's a separate CLI for Lightsail.
There is Lightsail CTL.
That's something else, right? The thing you showed, the commands you pasted are AWS CLI. They're all prefaced by AWS, and they are all basically just the AWS CLI. I'm gonna post the link in the comments here in the chat. So this is the Lightsail thing.
We are curious. Let's see what happens when I run the command. It says, see here. Here's the thing. So
no, it has.
You can see error arguments are required. Service name, image label. So yep, it's built in. So we don't have to worry about that anymore. Cool. So now the next one up from that, in terms of like how you would run, is like, once again, it's slightly more in the, I might want to go microservices. I want to access some additional AWS services. Now it's kind of like a pick between, do you want to go Elastic Beanstalk, or do you want to go, let's say, ECS with Copilot?
Okay.
Yeah. I personally, I know not a lot of people are a fan of Elastic Beanstalk for various reasons, but for containers, I am actually still a very big fan. Okay. The reason for that is that I've got some code over here from a previous demo that I did, which is, let me just make this a little bit bigger. Okay, cool. Now you can see. So this is just a simple webinar thing that I did a few years back, I think, well, almost 2 years back. And you can see it's got a Docker file. It's not very complicated. It copies a single static file, and then we want to get this deployed. So I created a code build job spec file for this. Now, it does look like there are a lot of lines in here, but let's quickly look at what it is doing. It's installing the latest version of the AWS CLI and then confirming it, which if you pre-build your code build image and keep it fresh and link it to your jobs, that makes it simpler. But once again, it depends strikes, in the sense that adding that capability to cycle out the different build containers and then configure your build system to change those containers as you move along does require extra automation. So it's that trade-off of, do I want to go into that level of automation and manage it on that fine-grained level of control for something this simple, where it's, I can just always upgrade to the latest CLI, and when it breaks, I go and fix it. It entirely depends on what kind of stage you are with what you're building. So this is just, once again, if you're fairly early, this is the way I usually recommend it to people. Then just a little echo command to see what we're doing in the build. And then what you can see is that execute this command that says, does an ECR login for us? And these are all part of the pre-build steps. So you've got the pre-build, build, and then the post-build steps. And this is, you can't put this all together in one thing. Kind of up to you. Once again, it's nice splitting them so you can see where's the actual build versus the additional steps. It's just for clarity to make it a bit simpler to see. Then what you can see is I set up two vanity environment variables just to make it a little bit simpler. The first one is the ECR repository URL. You can see it's very well named, called webinar, so descriptive. You know exactly what you're going to be running in there.
Exactly.
And then also creating the actual image tag. So that uses the SHA hash of the container once it's built. The reason for this is we generally don't want to have, what do you call it? Latest. Whole long discussion about latest. We might get to it at the end, but basically using latest is effectively doing YOLO.
Exactly.
Yeah, because it can change the whole time, and it's so common for people to use it, and it's the default behavior if you don't specify tags. So
Yeah.
it's a little complicated. And sorry, I just need to switch off the aircon because we are in those funny days where it's kind of hot but not hot enough for aircon the whole time. There was a question here, which is around line 9 in a subshell.
Yeah.
Yes.
So yeah.
Let me quickly show you that while we've got that here. I need to copy the code first. So if I grab this command as is and just paste it and run it, what did I do wrong? Invalid choice. Oh, you know what? I need to go double check this command again because I upgraded to the V2 of the CLI. But effectively what this one outputs is something like Docker login.
Yeah.
I think it's username something and then password, some long thing, which is actually a command for Docker itself. So the reason why we have it here inside this $ brackets to run as a subshell, like who's it who pointed it out? TypeScript T-time, is it executes the command in the brackets, takes the output of that, and then runs that as a command, which is effectively just an easy way to get the Docker daemon logged in to your wherever it is you want to log it in. In this case, it's ECR.
Okay. Yeah. Okay. Awesome.
Cool. That's just it. And then all we do over here is we just make a call to make sure that the Docker agent is actually running, because with code build itself is inside a container, you run into that whole Docker inside of Docker versus Docker outside of Docker. It's a whole fun world to dig into. But effectively what happens is that you, inside the container, start up the Docker daemon instead of connecting to the outside Docker daemon of whatever's daemon, running it, because it's obviously a security concern. If you have a build container and it's running on a host somewhere in AWS, we aren't going to give you access to that outside Docker. It actually uses what we call a firecracker under it effectively, but we're not going to give you access to that one because that obviously gives you access to that host. So you need to start it up inside your own little container and then use that to build and connect to yourself. It's a little like Inception style container fun.
Can I just stop here and insert a really bad joke I heard?
Oh, awesome.
How do you start a Matt Damon? Actually, how do you configure a Matt Damon?
I have no idea.
You use some JSON born. I'm sorry.
There are so many layers to that joke.
Yeah, there's so many layers to that joke. Yeah, I know.
Darko, that is impressive. I like it.
I'll stop. Okay, yes. Continue, please.
Cool. So basically, then what we do then is that the next one is like, this is just a little over the years having figured out that it takes a few seconds to get it up. It's just a 15-second timer to say, listen, keep going until you can actually see that you can connect to that socket and make sure that it's up.
Okay.
Because otherwise, cool. And then the hardest part, building your container. Super complicated, as you can see.
Yes.
This is one of the reasons why Docker is so popular. It's like everything is inside the Docker file. You just go Docker build, give it the tag to apply to the container, and that's it.
Indeed.
Yeah, cool. Now, this is also, the reason I'm going through this slowly is this basically build job applies to almost anything if you want to build a container and push it to any of the other services as well. It's like,
gotcha.
You can copy and paste this. It's here at the end where things are going to change just a little bit for you, depending on how you do it. Then once again, just, echoing to say then what we do is over here is we do a quick push to the repository. And because we did that auth command earlier, I can push directly to ECR now, and it also tags it. Okay. There is, however, a little tail over here, which is interesting. Why do you think I have that in there, Darko?
Because Does a Docker push not give out the return of 0?
It depends.
Okay.
So
Yeah, always success. That's just you make your
yes,
stuff work.
the reason here, once again, you saw that this was for a webinar, so here
Yeah.
is the reason for this.
Okay.
What happens is, if you don't change the content of a Docker file and it builds, it ends up outputting the same hash, because guess what? The same input gives you the same hash output.
Yeah.
What that does is that ECR is a feature that says you are not allowed to overwrite images in terms of with tags. So if I create a hash and then I try and push it, it wasn't there before, great, it goes through. Now I push it again and it breaks, which obviously as you're doing a demo and you need to run the command multiple times without actually changing the container, that then breaks. So that's why I put that in there.
Okay, makes sense. Makes sense. Yeah.
Yeah, it's as you know, sometimes build systems are janky. One day when we really want to tell war stories, I'll tell you how I use Jenkins build agents on different Windows machines running as admin to do deployments by kicking off Jenkins jobs on them. But yeah,
Right.
that is for
that, you know that GitHub process, GitHub project called Volkswagen.
No.
So it's a project on GitHub somebody made. Basically, it detects when your tests are being run within a CI server and just makes them pass. just, like it just force passes them for you. There you go. So
yeah.
Good. Okay, so what's the artifact of this?
Cool. Let me show you quickly, just before we get to Surly Dev's question. Just to show you now, like I said, this is a demo specifically on how to use Elastic Beanstalk. And the reason for this is that now what you do is you can see over here, this line is the magic line for ECS.
Okay.
And this here is the magic line, it's a little bit longer, for Elastic Beanstalk. And what you can see over here is that for ECS, what this contains is literally just that string. It just tells it the name to give the service you're going to run, and also give it the URL of the actual image. And then, before we get to the next one, or what it does after this, with Elastic Beanstalk, the JSON file just looks slightly different. You tell it to use Docker run version 1.
Okay.
This is a version. This is not the number of containers that you run. People sometimes get confused about that. But basically, you give it a little bit more details, like, for example, similarly, the name of the image you want to run, update true, because if you already have one running, you want to tell it to redeploy it for you. Right. And then you have to specify a little bit more to tell Elastic Beanstalk which container port to actually send the traffic to. Because if you've got multiple containers in this definition, then you can actually have multiple ports exposed, and it doesn't know how to choose that. I mean, you have to tell it which one of those to connect through first. Okay. And then you just pass in values in here. You can see, for example, which tag and which repository URL to use into a Docker run file. Okay. Now, that outputs image definitions.json and dockerrun.aws.json. Both of these are then inside code pipeline. There's a way in a stage you can say, run this code build job. Okay. Once it succeeds, run the next job, which is a deployment job. And in there is a drop-down saying, I either want to deploy to ECS with selecting the cluster, or I want to deploy to Elastic Beanstalk, selecting the actual application. That's it. Because these two files are in there, each one of those, when code deploys does the actual deploy, will take that file, read the info, and then pass it on to the service for you, so you don't have to worry about running any commands. And that's kind of my favorite way of getting started with containers, because both of these services, in terms of Elastic Beanstalk and ECS, only charge you for the EC2 instances that you're using under the hood. Yeah, which is awesome, because it means like you just pay whatever the infrastructure is. There's no additional management fee cost on top of it, like for backplane or anything like that. So
tell me, Kubas, you mentioned here like Elastic Beanstalk. So when would be the appropriate choice to choose Elastic Beanstalk for running your containers? Like when would you choose that?
So Elastic Beanstalk is kind of in the middle between running all of your infrastructure inside AWS using EC2 and RDS on your own, where it's got like a management interface across it, where it makes it easy to say, this is a single app. For this app, here's the complete section, run these type of instances. Here's the database using RDS under the hood, run those, share the credentials between the two with environment variables, and configure it and manage it all like a single unit. Yes. So it's like a mini project inside there, versus where ECS, it's a normal AWS service with all the ways you would normally do. So ECS only has the container portion of your cluster. If you want to add normal relational database, you go to RDS, add that. make sure it's deployed in the right subnets, and deal with all of that complexity. Share the credentials via secrets manager or browser store and deal with it, where Elastic Beanstalk just abstracts a little bit of that away from you, especially like, for example, the load balancer.
Okay.
Once again, many ways to do it. You can use the guided wizard in ECS to actually launch it as well, the load balancer connected to the service, etc. There are lots of different ways to do it. So
okay, good. Yeah, I mean, I've worked with a lot of customers who just run their full container workloads on top of Elastic Beanstalk because they still want to use EC2 instances that are fully managed by AWS, but they want some sort of an orchestration on top of that, right? So that is definitely the case here. Okay, cool. So go ahead.
That question. So now that we've covered this, the question is here, which is, I get that having configuration and deployment scripts as code is desirable sometimes over point and click in the console. However, the console gives discoverability that's not as easy to fathom sometimes, so it is easy to reverse engineer a configuration Docker file from the options that you choose in the console. Yes, so this is that classic catch-22 situation where you don't know what you don't know. Whereas the console, because it's visual, allows you to see things and additional prompts and hints and things, where the command line just spits back an error or spits back a success message with some status output. And over the years, I mean, this was exactly my journey. I started AWS just doing clicking around in the console to figure out what are the base constructs, how do they relate to each other, is there anything. Then when I had to start doing them over and over again, then I went to okay, how do I automate this, which led me to the CLI, and then infrastructure as code tools around the way, started playing with those. But I often use the console still to view things and what's the state, troubleshoot, dig for issues, and all that as a combination using the CLI. And it's one of those, it takes time. So both have value. And also, at the end of the day, once again, it depends what you're doing and how often you do this. If it's something where it's literally a one-off and you're just playing, or it's something you only do once, you can spend a day or 2 days automating it. It might be hard to justify the value, especially if you, let's say, in startup mode, where it's get the thing out there. We've got customers who need this, working with it. The higher focus there is customer satisfaction than engineering excellence. Yeah.
Okay. No, absolutely. Okay. So more questions coming in here. Like one from Adrian. Like, what should we use? Vanilla Kubernetes, ECS, EKS, Lightsail, Proton, Beanstalk, EC2 with Docker installed, Copilot, App Runner. Batch, code build, and all those things. I think we need a Nations of the World song here for this.
Oh yeah, definitely.
There's a lot of choices again, but depends on your situation.
Yeah, the one that I would say here is that I would highly discourage, unless you are very experienced, is vanilla Kubernetes running it yourself. Even if you use what is it? I haven't even used this so long. I can't remember the name. That CLI script that allows you to deploy a Kubernetes cluster on EC2. It sets up all the primary nodes and then some worker nodes for you, etc. It's Cube something. Someone will remind me at some point. But that, unless if you've ever looked under the hood how Kubernetes works, it should scare you, because there are so many different components running and talking to each other. There's even sometimes like sleep containers, where a container just runs for 30 seconds to sleep, do things, and comes back. I personally have not reached the complicated project enough to say, listen, you definitely need Kubernetes. It's always easy to say, well, use it. It's good for my CV, good skill to build up, great jobs, opportunities in the future. But it's there we go. Castrol's got it, or Kiram, Kops. Yes, Kops is the one. So
I used Kops. I remember using Kops back
Kops. It's like you configured what cluster details you wanted, and then it went away and did all the things. But yeah, so which ones should you use? Well, it depends. My personal favorites are ECS, and especially if you only have a few services that you're going and you start playing with microservices, is use Copilot and play with it, because it helps you abstract away. So, for example, it'll set up your CI/CD build job, push it to ECR, set the permissions up to pull from the host they use with Fargate, all of those things for you. And the nice part is, like the previous question, you can go dig in the console to see what was built. You can also look at the CloudFormation stack, which, if I go in here, should have one. Because I spun up a service. Let's look. Come on. Sorry, I'm connecting halfway across the world.
Okay, yeah.
Here we go. Let's open up that one and that one. So what you can see over here is that we've got.
Can you zoom in a bit, Kubis? Just gonna
Unzoomen, unzoomen.
Zoom.
Let's close that. That better. There we go.
Better.
Cool. That's really big. So here you can see it's got an IAM role. There's an ECS cluster. There's a load balancer. There's some routing. There is a Lambda function that helps us with things, role security, etc. And then in here, the API itself, if we look at resources, let's just close that again, is here we can see there's another IAM role, service discovery, another IAM role, load balancer rule. And this is important. Remember, if you think about your infrastructure, the base creates the load balancer. The service being deployed creates the actual load balancer rule, because it's associated with the service, and that's how you split your infrastructure to reduce the blast zone and actually bring up a service and bring down a service and create it cleanly for you. But I didn't go ahead and figure out how to do multiple stacks here and reference them and all of that. Copilot just did it for me. So
yeah, that's the whole point. Right?
So yeah. And so from here you can see, so the nice way is if you want to learn what was created, go look in the CloudFormation stack what resource was, and then you can go click on it. Let's see quickly. I think the rule, I should be able to click on it. No, that's the error. That's actually sad that it doesn't have the look. So you can see over here the IAM role you can click through, but I don't seem to be able to click through to the listener rule. But yeah, that's how you can go ahead and play with it again.
Yeah, so but basically there's a lot of benefits to running things on ECS and all these platforms. Again, today we had a look at like running from the simplest light sail, running a single container instance from a public image you have somewhere, to going a bit more advanced and looking at running things in Elastic Beanstalk, which is a way to run containers on top of EC2 instances in a semi-automated fashion. But then we get to the things like, your ECS clusters, your Kubernetes, your standalone Kubernetes, your EKS, your Elastic Kubernetes services, your Copilots, your app runners. With the level of complexity you gain, that's how much your application requires. That's how much you increase the complexity of your infrastructure. So if you would run a single container-based application or an applet or a appliance, you can run it in a single container. You shouldn't care too much about services, about tasks, about clusters, about any of those things. Like if you want to do something more complex, where you have a service map, where you have multiple different things talking to each other, doing blue-green deployments, this is where you talk about more ECS or more orchestrations like that, right? I cannot talk too much about Kubernetes because I really have not worked with Kubernetes at all. So I really am very much in the I don't know anything about this. But yeah, like ZB mentions here, they've been using ECS for scheduled tasks. That's a wonderful way to doing it. I've seen people basically just running some things at a point to just trigger a task, trigger a container on top of ECS, right? Mohammed mentions here, it is a cost factor. It is definitely a cost factor. Depending on what you're running, you may not need an EC2 instance to do it. Maybe just a Fargate from time to time. Or if you have a long-running collection of containers that are running all the time, an EC2 on ECS plus like a savings plan would save you a ton of money.
Oh, there's even more fun you can do there. I can probably speak an hour long just on how to optimize these things, because you can use auto-scaling groups when let's say you're using EC2 hosts for your actual compute, because remember there are two ways with both ECS and Fargate, ECS and EKS to run your worker nodes, which is EC2 hosts, which are VMs that you have an agent running on and it deploys the container there on it, or you can use Fargate, which is a serverless container hosting option, which means that you tell it CPU, RAM, container image definitions, go run this for me, and it runs it. You don't have to worry about capacity. So that's the difference. Then for each of these, there are multiple ways to actually reduce the cost by using either the default instance types or using spot instances. And for both of them, you can actually combine default with spot instance values as well. ECS has got a concept called capacity providers, and it can use normal Fargate or Fargate spot, and you can blend the two with weights and values between them. And on the EC2 side, it gets even more fun because you can build a whole spot pool of different instance family types with priorities, with how to scale them and allocate them, so that if some of the spot instances go away, you go to the other family. Whole bunch of fun things you can do over there. It's it actually gets quite a lot of fun dealing with those API calls as well, because they're huge.
So like kind of like to potentially give the ultimate answer to today. And today's question was container options. What should you use when and how? What is the best container option for your work, your use case, yourself, or whatever you're doing there? Would you have like a Cobus? Would you have in a couple of sentences a guide to the people here?
Yeah.
How do they go about to choose which container service is the best for them?
Yeah. So if I just want a single container to run that I'm building locally and I want to get that up and running, I'd probably go for App Runner at this point in time over Lightsail. The reason being is that with Lightsail, it's quite a few commands. I need to pipe things into a JSON file that I then pass to the service and do that. Therefore, between those two, I'd go for App Runner. If I need a little bit more functionality, like adding a relational database, scaling, automated deployments, those kind of things, I'd probably go for Elastic Beanstalk. Once again, with a simple app. As soon as I start going microservices, then usual answer is ECS.
Yes.
And ECS will be then, I'd probably, just because of my background, go for ECS directly because I know how to wire everything up and all that. But if it was new, Copilot for multiple services. That'll just make it easy for you to actually get all the components and learn from it. And then if I really want to go build a online platform for the whole company that multiple teams will be building, let's say a SaaS product on, then only would I start looking at Kubernetes. But also I'd first really weigh up, does ECS not solve it? Because like I said, there are pros and cons to Kubernetes, but it is extremely complex. There's a high learning curve. And also remember, it's very fast at evolving. They bring out a new release every quarter.
Yes, exactly.
And a lot of the APIs are still in beta or alpha, and they change over time. I mean, if you want to get a feel for it, just go look at the release notes, the breaking changes, how to fix it, and just ask yourself, do you want to go through that every single cycle and change things? Because remember, security vulnerabilities, you don't want to stay on an old version too long, etc. It's one of those like complete trade-offs, like how much skill do you have, knowledge in the thing, time to actually do this patching, people. But
yeah, but I mean, ultimately, it's a wonderful system. It can do a lot. That's the thing. And if your workload requires a lot, you do that. So ask yourself, how complex is your system? How complex is my system? What is this container going to be? Is it going to be a single appliance that does X? Is it going to be a web application or an application that just runs in a single or two containers? Or is this a microservice you need to run? And also ask yourself, do I know AWS? Like, what is this AWS? Is this something I know how to work with? If you don't know AWS, it's fine. Check out Amazon Lightsail. That's going to solve a lot of your problems. If you're dealing with a complex suite of microservices, check out ECS or EKS. Definitely. So that would be my take on that.
And also, have a discussion about what is your actual day job. That might sound funny, but are you there to get features out? Or are you there as, let's say, a DevOps engineer or platform engineer to actually build the platform out and build capabilities? Or like I used to do consulting, come in, make our dev teams more efficient, find the patterns, standardize them, put the best practices in place, and then train the teams to do that. So it really depends. Because, I mean, if your job is not maintaining a Kubernetes cluster all day, and you've been doing that for 3 months, when you get to that whole discussion around how are things going, it's going to be awkward.
Exactly. So figure those things out. Sometimes, ultimately you want to make your day job easier, right? So think about that. And you want to enable your fellow developers, your fellow peers to kind of do their job much, much better. So yeah. I mean, there's so many options out there, but don't be too scared of them. That's the whole point, right? Play with them. We give you this whole palette of things you should try. And I know we can get into discussions about, the paradox of choice and all those things. But when it comes to real life scenarios like cost, complexity, time it takes, this is where you need to stop and think about, okay, what am I building? What do I know? And how much time do I wish to spend on this? If you want to build your own Kubernetes clusters and your own data centers, by all means, right? But again, think about it. Is this what you want to do? Like, does this bring value to your ultimate product? So yeah.
Yep.
Don't rush into service. It depends. Yeah. Don't rush into products and tools and services because they exist. So, but yeah.
TypeScript
Think
tea
about
time
it.
quickly. If I point up here, you can see the YouTube channel. The video will be there if you want to go replay the video to grab that
Exactly.
comment and get us into trouble, or just the wise words apparently that we spoke. But yeah,
It's correct. It's all
Oh.
true, right? It's all true. We haven't
Yeah.
said anything bad. Again, think about what you do, right? Think about really what you do. So, and it's not about the technology. It's always about the people. So think about you and what you do, and how can you make your life better and your fellow developers better.
And also, best career tip ever: go figure out what you're actually supposed to be doing by chatting to both your manager and whoever they report to. So ask them what it is that you see as the best outcome. What do you want us to do?
Yeah.
Because often it won't be spin up a cluster and keep it running. It'll be have the app do X, Y, and Z. And that's a big
Exactly.
difference. That mind shift is fun, because sometimes you can use Excel to fix a problem and it's fine. Guess what?
It's perfectly fine. Absolutely. Absolutely.
Cool.
Awesome. Well, with that
We are
being said,
almost
I
out of
guess
time.
We're out of time. Thank you very much for joining us. Next week,
Teaser.
join us. Teaser.
Don't
join
spoil
us for
it. Don't spoil it. Don't
Yeah,
spoil it.
join us for something potentially special. So make sure
It
to
has
be
never
here.
happened before.
It has never happened before. So next time, same place, same time, 1 p.m. Central European Time, twitch.tv/AWS. Join us for another episode of DevBeardOps. We still don't know what the topic is going to be for next week, but we're going to try to make it really, really fun. And with that, we have even an outro. Oh my God, professionally produced show. So thank you all. And we will be seeing you next week. Bye.
Cheers.